Welcome to the second half of VPC Basics. This is the hands-on section of the event. Of course, check out the first video to find a little bit more about how VPC is put together. And of course, this is going to be the hands-on, so Alastair is going to show us how it's all put together.
To the AWS Management Console, and I'm connected to the Sydney region, and I'm just going to go into the VPC service. I've been looking at VPC recently, so it shows up here at the top of my site list, but I could just type into the search box here, VPC, and find VPC. This is true for any of the services. As the console loads up, we will find lots of information about VPCs up in the front here. And we'll find that I already have a VPC in the Sydney region. Now, one of the things is that there is a default VPC for every account in every region. It exists because there was networking before VPC, and we usually just try not to use it for anything. So normally the first thing we do is we create ourselves our own VPC that we're going to use in here. And you see that there are the two pieces of information that I said we needed. Was the name. I'm going to call this VPC Pizza, and you'll see why later. And the CIDR block. And if you remember from the previous video, I used 64.0.0.0. Did I put too many zeros in there? 10.64.0.0/16. Could choose my own CIDR range, and away we go. That's all that's required to create a VPC. This ID that shows up in here is one of the really common things in AWS. We normally have nice friendly names for objects in AWS, but we also have these internal reference IDs. They usually start with a couple of letters of what type of object it is, and then a big long string of hex.
Is this something that we have to keep very private, or is somebody could use to hack into it, or anything like that?
No, this is not a security risk in here.
Okay.
There is a whole security model around this, and we can talk about that in yet another video. This learning about AWS goes long and deep, so there's a long way in this.
Okay.
The thing I wanted to highlight is that this VPC ID is something that does show up, and usually when we see lists of objects, the object ID is the first thing that's shown, and our descriptive name comes afterwards. And so sometimes it can be useful to try and remember the last or first few characters for the ID of an object we're going to work with a lot, so we don't get confused about what object. We can't always see the names of the objects.
Okay.
Fortunately, AWS isn't nearly as consistent as I'd like.
Okay.
So now we have ourselves our VPC. We can see its ID and its name in here. We can see its CIDR range in here. One of the things that we want is to have public IP addresses attached to our EC2 instances that live in our public subnets. In order to do that, we have to turn it on. And so it's this edit DNS host names entry. And we just turn on DNS host names. That gets us nice friendly public DNS names rather than just IP addresses. They're not actually terribly friendly public DNS names, but it's nice to have DNS names for things. So turn that on for the entire VPC. Next thing I need to think about is creating some subnets. So I come across into my VPCs and I go subnets, and you can see a bunch of subnets already here that live in the default VPC. We're not going to use those. We're going to avoid using the default VPC. We're going to create our own subnet in here. And again, I've got to specify a name for it. So this is going to be Pizza Public. Choose which VPC it's from. This list does show us both the name and the ID. And then choose which availability zone we want it to be in. We'll talk about availability zones when we talk about high availability. For now, I'm just going to be putting everything in AP Southeast 2A. Then we have to choose the IP address range for this particular subnet. It must come out of the VPC's range. So in my case, it has to start with 10.64. And then for this particular subnet, it's going to be 1.0/24. Because that number after the slash is much larger, it's a much smaller subnet. It's a much smaller piece of that larger subnet that is my entire VPC.
Okay.
You remember from the previous video that all of my subnets must fit inside the range for my VPC. Create that subnet. Again, we get a subnet ID. If I close out that, we can now see our subnet. We can see that I've got a pizza public is the name for this one. I like having descriptive names. And we can see the CIDR range for it and that it lives inside the pizza VPC, not inside the default VPC.
Okay.
We can also see down the bottom in the description area, there's a section where it says auto-assign public IPv4 addresses currently set to no. Now this is my public subnet. When I create an EC2 instance in here, I want it to be accessible from the internet, so it needs a public IP address. Just as I had to turn on DNS names for the VPC, I also have to specify auto-assigning IP addresses for my public subnet. Simple, easy to turn on. But if I don't do this, my EC2 instances in this subnet don't get public IP addresses, and so they aren't accessible from the internet coming inwards.
And that's easily, you can see that pretty easy, right?
Yeah, you can see now you can see both the setting here on the subnet and then when you create the EC2 instance. It's just that you have to know when you create the EC2 instance, if it doesn't get a public IP address or public DNS name, the settings are back here. The public IP address is on the subnet, the DNS name is on the VPC.
Okay.
We'll see when we create an EC2 instance that you can actually override this policy setting as well. But for now, let's just create the private subnet as well. So same process. Create subnet, pizza private, again in the VPC called pizza. Availability zone again will be in AP Southeast 2A. CIDR block again is drawn from CIDR block for my VPC, and of course, because I'm talking while I type out nicely. Create this one. And now we have our two different subnets, our public one and our private one. The private one we don't need public IP addresses for. We're never going to allow incoming connectivity directly into the private subnet, so we don't need public IP addresses on it. Next thing is
how easy or difficult is it to mix those up, the public from the private, from this console, from this interface?
You'll see when we create the EC2 instances that they're listed side by side. So you can absolutely see them. And people who are working with IP addresses regularly will be used to the private ranges, the 10.0 range, the 192.168, or the 172.16 ranges,
okay.
The ranges that are allocated for internal use. So it's usually fairly easy to identify what's a public IP address and what's not.
Okay.
But it definitely, in the EC2 instance console that we'll see later on, it definitely shows up in two different places.
All right.
Next thing we need after our two subnets is an internet gateway. So let's create ourselves an internet gateway. You can see that there's already one here that's attached to the default VPC. We'll create a new internet gateway called pizza.
Want to be pizza delivery?
And then it's created. You know, I'm not making any guarantees around that.
Oh, okay. No, 5 minutes or less. Okay.
No, and currently New Zealand is on lockdown level 4 for COVID-19, and so even delivery pizza is not allowed.
Okay.
We're hoping shortly to go to lockdown level 3 where delivery pizza will be allowed. You can see that my pizza internet gateway has been created, but it's currently detached, so there's no VPC showing. I better attach it. Attach VPC. Which VPC do I want to attach to it? It will only show me the VPCs that don't currently have an internet gateway attached. And I can attach it there. Nice and easy. Remember that the internet gateway is a fully managed service delivered by AWS that gives me tens to hundreds of gigabits of throughput. It's a pretty impressive thing. Now, the internet gateway is going to allow my public subnet access to the internet, but it's not going to allow my private subnet access to the internet. That's going to require a NAT gateway. It's going to come over here to the left and find the NAT gateways. and we're just going to create a NAT gateway. In it, it says, what subnet would you like this NAT gateway to reside in? Well, I'm going to place it in my pizza public. NAT gateways reside in public subnets. And then it has this weird thing of an elastic IP allocation ID. This is a public IP address allocated for the NAT gateway that the NAT gateway keeps while it exists. If I had allocated IP addresses in this VPC, they would show up here. I don't, so I'm just going to say allocate me a new one. So now I have this public IP address, this 52.64.184.173 is allocated to this NAT gateway. That's the public IP address for the NAT gateway.
Okay.
Can go ahead now and create the NAT gateway. NAT gateway is now created. It says the next step is to edit your route tables, but let's just take a quick look at the NAT gateway that we've created. Current status in there is pending. Now, underneath the NAT gateway is actually an EC2 instance. It's a virtual machine. And so it takes a little while to create this new NAT gateway, to have this EC2 instance deployed out. So it will be a moment or two before we have access to the internet from our private subnet once we've done our route tables. But for right now, that EC2 instance is being created. So let's go and take a look at those route tables. We have two route tables here. The top one is for the default VPC. The bottom one is for the pizza VPC that I created. So this is that default route table for the entire VPC. And on the routes tab, we can see that it says just one rule in there. The entire IP address range, the CIDR range for my VPC is local. You don't need to find another route. So the default route table just says the entire VPC is local. We're not going to use this default route table. Usually you just don't use it at all, that you create route tables for each of your subnets. So let's do that. Let's call this one pizza public as well, because it's going to be associated with the pizza public subnet. Which VPC does it reside inside? Really important that we choose pizza here, because this route table can only be attached to subnets inside the VPC we choose.
What happens if you accidentally do the other way?
If I do the other way, then I can't attach it to, this route table can't be attached to subnets that are in the pizza VPC. If I attach the route table to the default VPC, it can only be attached to subnets inside the default VPC.
So you'd have to go back to that step, delete, and then start over.
Delete and create again.
Okay.
Yeah, you can't move a route table from one VPC to another.
Okay.
Now, to make this a little easier, one of the things we can do is up here in the top left, we can filter by VPC. Now, this control populated before I created the pizza VPC, so I'm going to need to refresh the page. And then I get a drop down in here. I can say, just show me things that are in the pizza VPC. Now it's a little simpler. I don't need to see all those default VPC things.
Nice.
But still, when I create a new route table called, actually it has done it, that's nice. It's populated out that VPC for me. So now when I create a route table called pizza private,
do you think that did
my VPC?
Do you think that did that because of the fact that you chose the specific VPC, or?
Yes.
Okay.
Yes, because I said filter to just one.
Yeah.
The VPC ID wasn't populated previously. Okay, so I can create another route table.
So that's actually a good way to do it, because then you don't mess up on anything. You're specifically targeting that VPC.
It's harder, definitely harder.
Yeah.
So let's start with the pizza public VPC, pizza public route table. So this route table is going to make this a public subnet. What does that mean, Jeffrey? What do I need to change in the route table to make it a public subnet? No, you still haven't, you're going to need to rewatch?
Yeah.
This is where I put the 0.0.0/0.
Oh, I see what you, okay,
thing,
yeah, okay.
Right? Yeah.
Okay.
My question wasn't clear enough for you. For this to be a public subnet, we must have that last resort route going to our internet gateway.
Okay.
And then we choose the pizza internet gateway. Notice here that what we end up with in the rule is the ID of the internet gateway, not the descriptive name. But when we had that drop down, we got to see the descriptive name.
Okay.
So now we have a route table that will make a subnet public, but currently it's not attached to any subnets. We do this through the Subnet Association tab. And here we select Edit Subnet Associations, and we say, I want this public, pizza public route table to go to the pizza public subnet. And it's done.
Nice.
Now my pizza public subnet has direct access to the internet and inbound access from the internet. Now I need to do a similar set of tasks for the pizza private subnet route table. Edit the route in here, add that same 0.0/0.
Yep.
And instead of choosing an internet gateway, now I choose a NAT gateway. And there's my NAT gateway.
So it's just the first 3 digits that will determine internet gateway or NAT gateway. It's the same.
So that name NAT here followed by some numbers. It's different numbers. So the numbers on the end are specific to this NAT gateway, but it's always a NAT object if it's going out through the NAT gateway. And if we go back to the pizza public, it was going out through an IGW, but you can see it's different numbers on the end.
Okay.
And then pizza private, we needed to associate with the private subnet. So now we have our VPC with 2 subnets, one private and one public. We have route tables between them. We have a NAT gateway to allow the private subnet to get access to the internet, but not allow the internet to get access to the private subnet. To see it in action, we should deploy some EC2 instances. We'll talk about deploying EC2 instances in another video. So Jeffrey, let's do some magic video editing and make the time it takes to deploy a couple of EC2 instances disappear. But we've got 2 EC2 instances here. Let's actually give them some names. So this one that I've got selected at the moment is currently in public. So let's also call him Pizza Web Public. And again, he gets an ID like everything else. But the things that we care about in this is if we come down into the description area on the right, we have public IP address and public IP DNS name. Because we turned on for the subnet that we should have IP addresses for the EC2 instances and they should get DNS names. Both of these are populated out. What we also have, so I'm trying to see around, on the left-hand side, there is the private IP address, and you can see 10.64.1.253. That fits inside the subnet called Pizza Private, Pizza Public with the 1. So the private IP address is the one that the EC2 instance knows about. The public one is the one that the internet gateway is using on behalf of this EC2 instance. So if I copy that public DNS name to the clipboard and open myself up a new tab, we can go paste and go, and we find ourselves at Big Al's Pizza. And you can see in here that there's this platform field which has the IP address in it. This particular website is one that I use for my demos, and it tells us which EC2 instance we're on. There's the IP address inside the private subnet. So we can see this EC2 instance in the private subnet. It's accessible from the internet because we've allowed it to be so.
Okay.
But we also created an equivalent EC2 instance, which I'm now going to call Pizza Web Private. And because I didn't try and talk at the same time as I typed, I managed to type successfully.
Good job.
You can see that it's also got a private IP address, 10.64.4 from the private subnet, but 153. But it doesn't have a public IP address, doesn't have a public DNS name. So there's no way for me from my laptop to get to that EC2 instance in the private subnet. My laptop's only connected to the internet. It's the demonstration then of having a private subnet that is not accessible from the internet, separate from the public that is accessible, and it was the route tables that controlled that. The route table that used the internet gateway made the subnet public. The route table that used the NAT gateway made it a private subnet. That's the hands-on demonstration of building these things. Things to catch out of it. Really the same principles we showed in the first video, where we talked about how these subnets are attached together and how you link them through route tables. You control how traffic goes in and out through route tables.
Mm-hmm.
I think one of the big things to see here is there was a lot more detail to configure. There is a wizard for creating a new VPC that handles this for you. But if that auto-created VPC doesn't exactly match your needs, you're going to need to understand all of the settings underneath, because as you have to change it to make things more suited to you, you have to make all those manual changes. So it is important, I think, to understand all of the manual processes that are underneath some of the wizards that you might choose to use.
So yeah, this is an advanced setup. Maybe someday we'll actually show the easy setup just to go through it. But
we could do that. Let's create an equivalent VPC using the wizard. So let's go back to the VPC dashboard and just launch the VPC wizard. And we wanted a VPC with public and private subnets. Cool. And the wizard says what we want for our range. Let's use a slightly different CIDR range. Let's use 61. Our first subnet is therefore going to be in 61.1. Our second subnet is going to be
61.2.
61. Well, I'm going to put it in .4 because that's what I used before, and I used a CIDR range of with a /22 on the end.
Okay.
But now we've got them called public and private subnets. We don't have an elastic IP allocation already. That's going to stop us from completing this. So we're not actually going to be able to complete this wizard because we haven't already got an elastic IP.
Would you have to set that up? You'd have to set that up beforehand.
Yeah, so even the wizard doesn't do that for us. That's kind of disappointing that the nice hand-holdy wizard leaves out the elastic IP allocation. That's not hard to do. It's a few clicks back in the console if we went back.
Okay.
So you know what? Let's not complete this one out today. I hadn't actually planned to do it. Otherwise, we would have done the elastic IP.
We showed the idea. We showed that there is a wizard and there's a long version and advanced version if you need to get more hands-on with your setting up your numbers.
Yeah, and one of the things that these wizards are really good for is if you don't actually want to learn how to do this piece, this is the necessary work before you can learn about something else. The wizards are awesome to get you through the thing you already know how to do quickly. Well, Jeffrey, we've created VPC, we've created some subnets, we've linked them together, we've even made a public-facing website. Down to our menu. Yeah, I have a pepperoni for $23.
Oh, but you have a margarita pizza too. Oh, that's not. Oh,
I do. It is my favorite.
I'm a pineapple guy on a pizza, so Hawaiian sounds pretty good. So, what VP? You should have a VPC pizza here.